Okay, in the previous video, we talked about multiplicities. And so now we're going to actually talk about what do multiplicities do to the graph? How does it impact what the graph looks like for these polynomial functions? So first, let's talk about odd multiplicities. So if you have a factor that has an odd multiplicity, again, remember that's the exponent for that factor, then that means the graph is going to just pass through. This function is just going to pass through the x-axis at the 0. So it just continues on in the same direction. So a quick example of this is if this is the x-axis and let's say this is the 0, let's say 2. We're just using this as a quick example. Then if the function is coming along like this and it gets to 2, it's just going to keep going. And it would be a smooth curve here. Okay, so it would just continue to go through. But if that multiplicity is even, so let's say you've got a factor that has an even multiplicity of 2 or 4, then for that same, or this would be a different 0. So let's say you have a 0 that's like 3, okay? Then if the graph is coming along, it's going to get to 3, but it's now going to turn the other direction. It will bounce off the x-axis. So it's going to go like this. Okay, so it's going to go up and then hit it and then turn the other direction. It could also, like let's say this is the x-axis and this is the 0. It could come from the top and hit it and go back up. Okay, so it doesn't matter which direction it's coming from, but that x-axis is almost like acting like a wall where let's say the function is a ball and it's going to hit it and bounce off, whereas when it is an odd multiplicity, it's going to completely pass through and just keep on going, okay? So all of that said, let's look at these two examples that we have. So f of x equals x minus 3 times x plus 5 squared. So first question, what are the zeros? So again, remember the zeros are taking each factor and setting it equal to 0 and solving. Again, by now, I'm hoping that you know the pattern and that you know that if you take x minus 3 and set it equal to 0, you're going to get 3 out of that. Same thing with the x plus 5. If you set that equal to 0, you're getting negative 5 out of that. Next question is asking which of these zeros bounce, and then you've got to add, and then they're asking which of these zeros pass through. Okay, so again, the thing that is determining whether something bounces or passes through is the exponent, not the 0. So I want you to go back to the function and ask yourself, if my 0 was 3, what was the multiplicity, what was the exponent for the factor where that 3 came from? Okay, so if you go back and look, this 3 had a multiplicity of 1. This has a multiplicity of 1. Okay, so that's odd. Let's look at the negative 5. Its multiplicity is 2. 2. That's even. That's even. Okay, so now let's compare which is which. What's happening here based off of that. So we know that it is going to bounce if the multiplicity is even. And so we know that our 0 is negative 5. That multiplicity is 2. That is even. So it is bouncing at negative 5. And then which of these zeros passes through? Okay, and so we've got a 0 of 3 that has an odd multiplicity of 1. That's going to pass through. So the 0 at 3 is going to pass through. And then it's asking, okay, what are the x-intercepts? So remember, we're just taking the zeros and turning them into points with the y values being 0. So this would give us 3, 0 and negative 5, 0. Okay? All right, real quick, I want to show you what this might look like on a graph. Okay, I'm not graphing the whole thing. But if this is your x-axis and this is y, and let's say over here is negative 5 and over here is 3, okay, we're just sketching this. And if we put all this together with our end behavior, we know that the leading term is x to the third. Why is it x to the third? Because we added up 1 and 2, okay, and it's positive. So we know our end behavior to the right is going up, our end behavior to the left is going down. So we know it's going down over here, and then this is going to go up. And what's going to happen at -5? Well, this is telling us it's going to bounce. So that means it's going to hit -5, go the other direction. And then at 3, it's going to pass through. So it's going to go down, and it's at some point going to go back up and pass through 3. So that would be kind of what the graph looks like. Now, is my pen doing very well with this? Clearly not. But you're looking for something coming up, hitting -5, bouncing the other direction, passing through 3, and then going up onto infinity. Okay, so that's what we would be looking for in a graph. Let's look at our next example. We've got f of x equals x squared times x plus 1. What are the zeros? So again, we're setting each factor equal to 0 and solving. Remember that if you just have an x with no number there with it, x equals 0 gives you the 0 of 0. Okay, so this is going to be, this x squared will give me a 0. And then x plus 1 equal to 0 is going to give us an x value of -1, so that'll be the other 0. Which of these bounce? It bounces if it is an even degree, even multiplicity, even exponent. So look at your even exponent. It's going to be the 2. What 0 came from that? The 0 came from that. So it's going to bounce at 0. Which of these passes through? That's going to be your odd multiplicity. This is your odd multiplicity there. And so -1 is a pass-through. And then writing these as x-intercepts would be 0, 0, and -1, 0. So if I wanted to sketch that real quick, again, this is just an example. Here's -1, here is 0, clearly. The graph is going to go through those 2 points because they're x-intercepts at -1. So be careful, the way you list it may not be what the order of the graph from left to right, okay? So -1 clearly comes first on the number line if you're going from left to right. So at -1, this is a pass-through. So it's going to come from the bottom and pass through. And then 0 is a bounce. So it's going to go back down, hit 0, and bounce back up. Okay, still having the end behavior of up on the right, down on the left, because we have x to the third when you add those two up. So that's kind of the general idea. Let's look at 2 examples that have graphs with them. So this is multiple choice. We love that. But it could be a little confusing because all the graphs look real similar. So all the information we just went over is the key to knowing which answer this is. So let's look at this first one. We're graphing f of x equals x plus 4 squared and then x plus 2. What's the degree of this function? So remember, the degree is adding up the multiplicities, but even the ones you can't see. So 2 plus 1 would give us a degree 3. So we know this is an x cubed. It is positive in the front. We know that end behavior is going up on the right, down on the left. Unfortunately, that does not help us with any of these because they all have that end behavior. So what's the next thing we need to know? Well, we need to know the zeros. So our zeros are -4 and -2. And then let's determine if we are bouncing or passing through. So again, even degree is going to bounce. And odd degree is going to pass through. Okay. All right. So I would first look at the graph and make sure that, you know, it has the points -4, -2, -4, 0, -2, 0. Those are our x-intercepts as points. So here, this first one does indeed have those as x-intercepts. So that's a possibility. We'll talk about the bounce and pass through in a second. The second one here and here, 2 and 4 are not what we need, but obviously if you don't change those signs, it has an option for you. Okay, -4 and -2 are a possibility, and 2 and 4 are not. So we can eliminate 2 options just by knowing the zeros. Now let's talk about bounce and pass through. It is bouncing at 4, -4. So if you look at -4, I'm looking for a bounce. This means that it's going up, hitting it, and turning back down. This is almost like it's becoming, you know, I say this sometimes and it's a little bit helpful for my students. Think of this like a little mini vertex. It's not a parabola, but think of it like a little mini vertex max, okay? That is what you're looking at here. You're looking for like a little max right here, or min at -4. And so we do indeed have this turn where it hits that x-axis and bounces off. And we also can confirm that -2 passes through. So it looks like this is our answer. But just to check, let's look at our other version. Here's our -4. It should come up and then hit and bounce off. And this one passed through and it had the bounce right here at that -2. That was like a little mini minimum, right? And so this is not having the correct bounce in the right place. So the first one is the answer. So this is kind of what you're looking at. First to find the zeros and then the bounce is correct, okay? Let's look at our next one. We've got x squared times x minus 3. What's the degree of this function? Well, if you add our multiplicities up, 2 plus 1 is 3. So we know, or again, I kind of said this happens a lot where our end behavior is up on the right, down on the left. Let's look at our zeros. So our zeros here are 0 and 3. And then let's talk about bounce or pass through. So this is going to be 0 has a multiplicity of 2. This is going to be a bounce because it's even. And then 3 has a multiplicity of 1. That's going to be a pass through since 1 is odd. So let's see if we can find 0 and 3 on the graph first. These x-intercepts are -3 and 0. That's where it's passing through the x-axis. So that's not going to be 0 and 3. Here we're passing through at 0 and 3. That would work. -3 and 0, no. And then 0 and 3, yes. So now out of the two choices that we have, we need to be a bounce at 0. So let's look at our first option. From the left side of the graph, follow it up and look at 0. What happens here at 0? Do we bounce? Do we go back the other direction, or do we pass through that x-axis? We're passing through. So this is actually a pass through right here. Here's your bounce, but it's bouncing at 3. So this is not going to be the answer. Let's look at our last one here just to verify. From our left side of the graph, following it up, we're hitting 0 and we are indeed turning the other direction, and then the other one passes through. So this is exactly what we need here with our bounce. Okay, hope that helps. It's very difficult sometimes to see. And if you're doing this on the computer and you can't quite see if it's going to be a bounce or pass through, sometimes hitting that little magnifying glass in the corner will help you, make it bigger so you can see it a little bit better.